Basics of coding with you. This is going to be extremely basic stuff. I'm going to talk about variables, conditionals, and functions, maybe loops. If you know about that stuff, uh, you can by all means skip this, or if you'd like a little refresher, it may be helpful to you. So when we're writing code for computers, we're giving the computer a set of commands that it's going to execute. So the computer, for the code that we're going to be writing, can only do what we tell it to do, and it's going to do exactly what we tell it to do. This can result in problems if we don't write our code correctly. We'll get an error and the code won't run, and hopefully the error that we get will give us some indication as to why the code isn't running. The other problem that can arise is we get a bug, which is where the code does run, but we don't get the results that we expect. And that's a little trickier. We have to go through and figure out where exactly the bug is happening and how to fix it. So one of the first things we will do in coding is to write pseudocode. So pseudocode is plain English or whatever language explanation of what we want the computer to do. We kind of explain it to ourselves first, and once we have a clear understanding of what we want it to do, then we can better write the code for the computer to do it. And when I write pseudocode, I typically use comments so that I can leave some of those comments in place as an explanation for what the code is doing. What I have open here is the processing interactive development environment. It's very similar to the Arduino interactive development, which is here. But it is different in that it runs on the computer instead of a microprocessor. It's based in Java instead of C. But the fundamental things I'm going to show you are the same and applicable to both. And at a certain time, I will switch over to Arduino anyway. I'm not going to be uploading anything to a board today, so I just want to show you some basic things. So our goal for the program we're going to write is to be, we're going to write a program that will add two numbers, a function. Very basic, we don't need a function to do this. It's built into the languages themselves, but as an example, it works. And so to write a comment, I'm using 2 slashes, and that makes the line a comment. A comment is a line that doesn't get compiled and nothing happens. When the program runs, it's essentially skipped. But it's an excellent way to leave notes to ourselves in the code. So what do we want to do for our function? So again, I'm writing pseudocode here. Well, we have to make the function. Our function is going to need to accept 2 different numbers. We want to then add those numbers, and then we want to return them. Okay, fairly straightforward. The other thing you may notice is I've got some unnecessary white space in here. That's fine. The compilers ignore white space as well. So to have numbers, the first thing I need are some variables to store those numbers. So Arduino, like I said, is based in C. It uses a strongly typed language, so that means you need to declare what type of variable your variables are in order to use them. So if I want an integer variable, I need to say that I want an integer variable. If I want a floating point decimal variable, I need to say that I need a floating point decimal variable. And how I do that is by using some abbreviations. So for an integer, I just say int. And you'll see in these IDEs, it's great. They color and highlight things as you go when you're using keywords. So I say int, then I give it my variable name. And I can name it whatever I want. I could name it Tom, I could name it X, I could name it cat. It doesn't matter to the computer, it matters to the reader. So we want to use variable names that make sense to what we're trying to do. So I'm trying to add two numbers. So I might just call them, in this case, x and y. So I might say int x. And this, I'm taking x and y from algebra, right? Very common variables in algebra, because that's what our function will be doing. Now, to end my line, I use a semicolon. All right, and there we go, int x. Now, so that gives me, that basically tells the computer I want some variable space called x of the type integer. If I look in the reference, here's the reference for processing, there's a reference for Arduino as well, I can find a data type. Let me see if I can find it. Yeah, here we go. So like int, well, this will do conversions. I don't want a conversion. Primitive, here we go, primitives. So the integer data type. And this is going to show you the range that it can be. So an integer variable can be anything from 2,147,483,647 to the negative of that. Okay, so that's quite large. You can have a quite large number as an integer, but you can't have the number 3 billion as an integer. It's too big, it's too much data, because the data that's reserved for that variable is only 32 bits. So if you need something bigger, then you need something called a long. Okay, so these primitive will show you all the data types for processing. Most of them are in Arduino as well: Boolean, byte, character, long, float, and etc. Okay, so I have an integer equal x. I've reserved that space in memory for x. I can give x a value at this point in time too if I want to. I could say x equals 0. So now variable x has an initial state of being 0. Okay. To check that, just to see that this is doing what I think it is, I'm going to say print x. Now this is a difference. Arduino does not have this kind of print function. I'll talk about how we can do a similar thing with Arduino in later videos. But if I say int x equals 0 and then I say print x and run this, in my console down here, I get the number 0, which is what I would expect. So it's just saying print the value of x to the console. Okay, so let's do something more interesting. We'll say x equals 5, and we can say int y. We'll make our y variable. We can set that equal to 2. And then we could say something like print x minus y. We'll see what that does. We run that and we get 3, which is what we'd expect. 5 minus 2 is 3. Okay. We can be a little bit more complicated with our variables. We could say int z equals x plus y. And then down here we might say just print z. And we get 7. Okay, 5 plus 2 is 7. That's great. I mentioned decimal numbers. If we wanted a decimal number, we would say float. We might say float d equals 3.12. That will give us a floating point number. Now we'll get into oddities here if we start combining these, right? So now that all these are declared, I can just reference them. So if I want to use the variable z again, right, like what I do here, I don't say print int z, because that would give me this error, syntax error. I'm trying to redeclare a variable. I could say something like z equals x plus d. Now, what's going to happen here, right? It's going to give me an error. Type mismatch, float does not match with int. D is a float, x is an int, z is an int. It can't figure out how to do this math. It won't run because of this error, okay? So I have to fix that. I have to either make float an int or make d an int or make x and z floats. Which I could do with these conversion functions, right? So I could say int and then parentheses around the d will make d an int, add it to x, make that z, and then I'm printing z. So what do we think is going to get when we run this? Get 8. Why? When we make a float an integer, it just chops off the decimal. So it's saying 5 plus 3. This line here, where we got 7 from 5 plus 2, is completely overwritten when we declare z equal to something new again, okay? To show this another way, if I say d equals 3.82 and run this, we're going to get the same number because it doesn't round when we make the float an int. It literally just chops off everything after the decimal point. So that's important to keep in mind when you're working with floating point numbers. There's other types. The only other one I think I'll show you right now is Boolean. We could say Boolean t equals true. A Boolean can only be true or false. That's it. And so we use these sometimes as flags for things if we want to know if a condition is true or false. And this is a unique case where we say the word true, and you see it highlights a different color. So t equals true. If we try to print t, what are we going to get? True. If we say t is false, it's false. Typically, as far as the language is concerned, on the underneath, false equals 0, true equals 1, because it's binary. So there's some basics of variables. We can do all of our normal operations that we can in math. We can say z equals x times y. We could say z equals x divided by y. If we do something like that, x over y, and again we print z, we're going to get 2. 5 divided by 2 is not 2, it's 2.5, but again we're working with integers, so it just chops off the decimal places. If we wanted to see those decimal places, we change our variables to float, sorry. Now we get 2.5, okay? Then, okay, I'm going to put this back to an int and then show you some shortcuts here that are just so common, like you have to know about these shortcuts. One of the ways we can increment things, incrementing things is a common coding practice. We want to take x and add something to it. Let's say we want to add 1 to x. So we want to say x equals what it is plus 1. How do we do that? Well, we can set it equal to itself. So we can say x equals x plus 1. And now if we print x, we get 6, which is what I expect. X is 5, plus 1 is 6. Now this is so common in computing that we have some other shortcuts for this. So one of those is we can say x plus equals 1. and that'll give us 6 as well. So it's saying x, take x and add 1 to it. We could change this. X plus equals 5 is 10. 5 plus 5, okay? And we can do this with other things too. We could say minus equals. So x minus equals 1 will give us 4, right? We could say x times equals. So x equals x times 2, 10. And again, like I said, these are very common. So the most common is to add 1 to something, and so we say plus plus. So x plus plus gives us 6, right? And so this was such a powerful method when first written that the language C++ is named after this function. We can also do minus minus. So x equals x minus 1 gives us 4. Okay, so those are some basic things, variables, and math that you should know about with programming. Going back to our fundamentals here, we want to make a function though. So we've done adding two numbers together, but let's say we want to do our own function that does that. We've used some functions here. Print x is a function. When I said int of this number, that's a function. So a function has a name, and then it has some parentheses that may or may not accept an argument. The argument is the thing within the parentheses. The function also may or may not return something. So when I said, for instance, when I said int of 3.82, that is going to return that integer value, right? So if I say print int d, and get rid of this, it gives us 3. So int d is returning 3, which is then being used as the argument for print. So I can nest functions and other things within other things as well, which makes code harder to read, but makes it take up less space. So it's a trade-off. So let's look at how we would write a function. To write a function, we give the function a type if it's going to return something. Our add function is going to return the sum of the numbers that we add. And let's say that our function is just going to work with integers for now. So we're going to say int and I'm going to call this add function. So that's the name of our function, add function. It's a type integer. It's going to return an integer. And then for its arguments, we need to give it some arguments. We're going to give it 2 arguments. It's going to add an integer named a and an integer named b. And we close our parentheses. So these are the 2 arguments it's going to take. We use curly braces to denote the code that is within this function, okay? And you'll notice it automatically indents a little bit. The indentations help us keep things legible. We know that the code that's in here is part of this function. It makes it easy to read. It like makes this a chunk. That's obviously gibberish. Every curly brace needs a closing curly brace. Every open parentheses needs a closing parentheses. You'll see the IDE highlight these things for you to show you the pair. One of the most common causes for errors and bugs is having mismatched curly braces and parentheses. So be very mindful of this. And I talk about that more in the debugging video. So our addition function, what do we want to do? Well, we want to add these two. So let's make a new variable called the result. It's going to equal a plus b. Again, these are declared here, so we don't need to declare them here. We do need to declare result because we haven't used that yet. So the result equals a plus b, and then we are going to return the result. So when this function runs, it's going to take A and B, add them together, and then send the result back as an integer. That's the basic structure of a function. There you go. Now, to test our code, we need to do one other thing here, which is unique to processing. But it's actually also shared in Arduino. So for this to run, for us to say something like print, or we could say we want an integer, we're going to call it sum. Oh my god, sum equals add function 6, 8. So we're going to add 6 and 8, and it's going to send us back the result. We're going to store it in sum, and then we want to print sum. This won't run because we're going to get this missing semicolon. We can try adding a semicolon at the end of our function. It's still not going to work. Because it's not, we're kind of mixing code here for the IDE. So stepping back a little bit, these variables, as they are declared up here, are global variables. Anything can access them. That's their scope. They're global. This int result, because it's in this function, if I tried to do print result here, where I'm not inside this function, I'll get an error because it will say result is not declared in this scope. It doesn't understand that. I'll show you that in a second. Our function is a global function. As it's declared here, anything can access it. This is really shouldn't be there. And then we're going back to declaring a variable, but we're starting to now we're running a function. We shouldn't do that in the global scope. With processing in Arduino, they both are set up when they run a snippet of code called setup, and then they do a loop indefinitely, both processing in Arduino. So we need those snippets now. So we've got our global stuff set up. Our setup, which is what's going to run first when we first run our program, is a function itself. It's a function that doesn't return anything, so it's void. The type of it is void. It has no return. It's called setup, and it doesn't take arguments. So it still has parentheses, but there's nothing in between them. And it still uses the curly braces, okay? So now I'm going to take these that were in the global scope, I'm going to take them out of the global scope and paste them into the scope of setup. So now we've got two functions, an add function and a setup function. What happens in setup is different from what happens in add. It's its own thing. Result is unique to add function. Sum is unique to setup. So now when I run this, it should work. And we get our sum of 14. So 6 plus 8 is 14. That's what I would expect. So what the program is doing is it's going through, it's ignoring all the comments at the top. It's saying, declare all these variables, make this function here. We're making the function exist here. And then we are saying here, use the function within setup to set sum equal to the result of that function, which is 14, and then we're saying print that. The setup function, like I said, is a unique thing to processing in Arduino. It runs once whenever the code is first run. So when I hit the run button, setup runs once. In Arduino, when you upload code and turn the Arduino on, it runs the setup function once before moving on. Automatically, it's the first thing it does. Well, after declaring these globals. That brings me to another point. Both of these languages, they run line by line, right? This line happens, then this one, then this one. It's never going to go back here. It's just going to go line by line through unless we introduce some kind of loop. So all of that gets declared, this function gets declared, and then setup runs. And then since there's nothing else, the program stops. Okay? Important to keep in mind. The order of things matters. For instance, if I try to print sum before I've declared sum, I get an error, sum cannot be resolved to a variable because it has not yet been declared. I'm trying to use sum before it exists in variable space. So that's an error. The other one I was mentioning was result, right? Result is unique to that function. If I say result here, I get an error. Result cannot be resolved to a variable. It is not declared in this scope of this function. It is declared in the scope of the add function. These variables are globally declared, so I can use them in this scope. Okay? This variable is not. It is declared within add. It is not accessible to setup. Okay? So these are complexities of coding that are important to keep in mind that will help you resolve those errors that you may get. What else can I say about this? You will notice we can put whatever we want here. It's A and B here when we declare the function so that we can write it. But it's not A and B here. If I say this, again, I'm going to get an error. Variable A does not exist, right? Because we're in the scope of setup. It only exists in this function, A and B. So I could, though, use my other variables, x and y, right? So from up here, I've got x and y. I have to make y an int again for this to work. And this will give us our sum 7, okay? All right, so that's a lot. I'm only going to show you a couple more things. One of our other fundamental elements is conditionals. But before I get to conditionals, let me clean this up a little bit. So we've actually completed our goal, right? The goal is to write a function to add two numbers. I'm going to move that here, get rid of that. So we're going to make the function that is this line. And I can add these comments at the end of a line. Everything after the double slash is a comment, but I can put it in the same line. So I can be like, this line is this. It needs to accept two different numbers. That is actually happening here too. That's that. We need to add those numbers. That's happening here. And then we need to return the result. That's happening there. So we've taken our pseudocode now and used it as comments to explain what's happening in our function. This can be very, very helpful when you're coding for two reasons. One, the comments let you know what you're doing. They also let me know, or anyone else who you're collaborating with, like your partner, read your code in a human English way that easily makes sense. This is especially important. All sections of your code should have comments at the very least saying what the section does. So the setup function runs once at startup. Up here we have global variables. So putting some headers in like that, minimum, absolute minimum. Now, when you're learning, I find a helpful thing to do is to do this commenting here, where you're commenting every line, right? It can seem tedious, but especially if you get stuck, you need to know what every line is doing, right? If you've got a line in there and you don't know what it's doing, why do you have the line in there, okay? So this is a way to comment like we do with a critique when we describe something to really see it first. Comment each line so you know what every line is doing, just for your own clarity and sanity, okay? Okay, so conditionals. Conditionals. Let's say we wanted our sum to be a bit more unique. We're going to add these two numbers, um, but we only want to return the result if it's greater than 10. Otherwise, return 0. So if the two numbers added together are more than 10, return the sum, otherwise return 0. So this is a much more complicated function. We're going to start out the same. We've got our add function, int a, int b. We want our two numbers. We do want to add those numbers together to get the sum, but then we need to add some things in here. So I'm going to use more pseudocode. We need to check if sum is greater than 10. If so, return sum. Otherwise, return 0. Okay. So to check if the sum is greater than 10, we use a conditional. So we say if. We use parentheses for our conditional and curly braces as well. So we're going to say if our result is greater than 10, do something. And something is that we want to return the sum. Okay. So we're going to take this from here and put it here. Return the result. So if result is greater than 10, return it. Otherwise, return 0. Let me come back to that in a second. Let's just see if what we've got so far is working. So add function x plus y. We run this. Method must return a result of int. So we get an error because the result is not greater than 10. X plus y is 7. So it does not return anything there. There is no other turn. We get this error. If we change our variables, what if y is 6 and we run this? We get the error still. And I'm guessing we're getting that error because it's possible that this can run and still not return something. Okay, so let's keep going and finish our code. In terms of the result, we can do things here. We can say if the result is less than 10, greater than 10, we can say greater than or equal to 10. If we want to say if result is equal to 10, so we're only going to run sign if it's equal to 10, we use two equal signs. That is a check for equality. If we said result equals 10, we would actually be taking the variable int result and setting it equal to 10, which would mess up the logic of our code. So that's also a very common bug to watch out for, because your code will still run, but it'll be wrong. But we want to say greater than 10. Now, if that's not the case, we say else. Otherwise, and this is our otherwise, return 0. So then if it is 10 or less, we are going to return 0 and close our curly braces. So you notice this if has like two sets of curly braces, really, that we need to watch out for. Now, let's see if this will run. And these are kind of tabbed more than they need to be. Okay, so here we go. Great. So having the escape basically for our conditional, the else, and having the two different return states, our result it's always going to be one of these two things. So it lets the function run, and we've got 5 and 6. Add 5 and 6. The result is greater than 10. We get the result. So let's change this back to 2 and try this again, and we get 0, right? Because the sum is 7, and we're returning 0. So why would we want to do this? I have no idea, but we're learning. Now let's try to introduce that bug here. Um, okay, interesting. So it's giving us a type mismatch. Int does not match with Boolean. So the default then, so if we're saying result equals 10, result is an integer, and if we don't have some kind of comparator here, uh, the if is looking for a Boolean type variable here, a true or false, right? Because this statement, result is greater than 10, that is really true or false. Um, so if it's not getting a true or false out of this comparator, it's going to give us an error. So that's nice. So maybe it'll help save you from that potential bug. And that's the IDE doing its magic. One other thing we might want to look at here, let's say we want to make this even more complicated, and we want to make sure that A itself is less than 3. Okay, so we can compare multiple things within one if. We can say, all right, if our result is greater than 10 and we use 2 ampersands, A is less than 3, return a result, otherwise return 0. So now if we run this, we get 0 because 5 plus 2 is less than 10. That is false. And A, which is x, which is 5, is not less than 3. That is false. So both of these are false. It doesn't compute. We can change this back to 6, right? So now we've got 11. So we're still getting 0. This is true, but this is still false. So both of these things need to be true for us to get the result return. Only if we say something like x is 2 and y equals 9 are we going to get a result of 11. Okay, because now the result is greater than 10 and A, aka x, is less than 3. If we wanted to be more forgiving here, we could say or, which is 2 pipes. So now if either of these are true, it's going to return the result. So here we could say make y back to 6. 6 plus 8 does not equal greater than 10, but x is still less than 3. So we will get our result of 8. Okay? So that is my quick overview of some really basics of coding. So let's look back at Arduino. And here you go. Here's your void setup. You put your global variables here. Then in Arduino, we also have this loop function. It is a void function. It has no type. It takes no arguments. And this is the code that runs on the microprocessor over and over and over again. So the setup runs once when you turn it on. It then moves on to loop, and it loops forever until it powers off. That's how the Arduino works. Our IDE is very similar. Instead of the run button, the 2 most important buttons here are verify and upload. Upload is what you use to upload to your board. Verify you can use to compile the code and check to see if you have any errors. If you don't, it will tell you something like this, how much memory the sketch uses and how much your global variables use. And I think that is it for this overview, basics of coding in strongly typed languages for Arduino and processing.